Okay, g'day students. Welcome to today's lesson. We're starting chapter 3. We're looking at solving linear equations today. So the key ideas are that you want to be able to solve an equation first of all by the balance method. And when we do this, we're going to perform operations on both sides of the equation to produce equivalent equations until you obtain the solution where the pronumeral, or for example x equals a certain constant. Now an operation can be undone by performing inverse operations. So a simple flowchart can help you decide the order of operations to undo. Now just remember, when undoing the operation, remember to work bid mass backwards. Now there is a little interactive you might want to have a look at. If you're in my class last year, we had a look at that. And this is just a little interactive. I think this is the equation or the equality explorer. We can do it with numbers and variables, for example. So we might just have a quick look here. And what do we do? I want to actually probably have to go back to a problem solving one. So let's say 2x equals negative 56. All we need to do is we select divide, and then what are we going to divide by? We want to divide by negative 2 to say that negative x equals 28. Well, now we'll have to divide by negative 1. Is that going to work for us? Yeah, and so this is saying, well, x equals negative 28. That's a one-step operation. We'll have a look at some two-steppers as well. But that's a good place for you to just refresh your memory from last year as well. Okay, so we're going to have a look at our first operation here, our first problem. So we want to solve 5x plus 3 equals negative 12. So what do we do to build 5x plus 3 first of all? What are we saying? Well, we're getting x, and we're going to have to multiply it by 5 to equal 5x. Then the next step is going to be saying 5x plus 3, and that will be our expression. So to undo 5x plus 3, so we've got 5x plus 3, you do this step first, and that's what we're representing here. So that's your little flow chart. And then to undo that 5x, we need to divide by 5 because it was the opposite of multiplying by 5. Okay, so if I were to do this using the balance method, I would write out 5x plus 3 equals, what did we say it was? Negative 12. Let's use a different colour as well. So I want to just think of bid mass, but I'm going to work it backwards. So I'm going to remove all the addition and subtraction. So it's just going to be 5x plus 3 minus 3 equals negative 12 minus 3. What you can see is that what I've done on one side of the equal sign, I've done to the other. So I rewrite this now to say 5x equals, now negative 12 take 3 has got to be negative 15. Now, what's the opposite of this times 5? It's got to be a divided by 5. So what I'm going to do is divide both sides by 5, and then I'm just going to write x equals, well, negative 15 divided by 5. 5 3s are 15, so this has got to be negative 3. So this is the amount of working that I would expect to see you doing in your book. Let's have a look at the next one. This is just a check now. So if we were to, for example, to verify our work, what we would do is just say, well, 5 times negative 3 plus 3 equals negative 12. So this is our check. Well, 5 times negative 3 is negative 15. Negative 15 plus 3 is negative 12. So negative 12 equals negative 12. And we have checked our work. So left hand side equals right hand side, and so we're quite happy with that we have checked to see that our answer is correct. Now if we have a three-step equation, we're going to have to work, what was it, BIDMAS, but we're going to have to do three different steps. So if we've got here 3x take 11 divided by 2 equals 8. So 3x take 11 over 2 equals 8. Let's just see what's happening to x. To build this expression, and I'm just looking at the left-hand side of the equal sign, first of all, I have to do my multiplication to get 3x. Then I need to take 11 because we're on the top of the brackets. So the top of the brackets is really, top of the fraction sign is really like a brackets. And then you can think of this like brackets there. Because we've now got this as a fraction, we're going to have to just say divided by 2. So there are three steps that we need to undo. So to undo 3x take 11, we need to just work this backwards. So instead of dividing by 2 here, we're going to multiply by 2. So let's do this. 3x take 11 over 2 times 2 equals 8 times 2. What you can see is this 2 and this 2 cancel each other out. So we've got 3x over 11 now equals 16. So let's 3x take 11 equals 16. You can see that I've left a little bit of space there because what I'm going to do is add a little bit more in there. So you can see the next step is the opposite of take 11 is to add 11. So we're just going to go plus 11 and plus 11. So you can see that I've just used this flow chart to do the balance method. Now 3x take 11 plus 11, well, that cancels out to be 0, doesn't it? So minus 11 plus 11, so it's just 3x equals 16 plus 11. So let's rewrite this, 3x. Now 16 plus 11 is 27. And so the third step now is, according to my flow chart, is just divide both sides by 3. So let's do that. So that divided by 3, that divided by 3. We can say, yes, well, x equals 27 divided by 3 is 9. Now, we just want to check that. So this is our verification step. We'll call that in the senior. Does my left-hand side equal my right-hand side? So I go to my original expression, 3x take 11 take over 2 equals 8. So let's do this. 3 times 9 take 11 over 2 equals 8. Well, 3 9s are 27. 27 take 11 is 16. And 16 over 2 equals 8. So left hand side equals right hand side. And we have checked our work. Now let's have a look at this one. We've got an equation where the variable is the denominator. I'll show you a little trick after this, but we'll just go through this. Well, 12 over x equals 3. I can do this two different ways. I'll show you the quick and easy way. First of all, we can just say, if that's true, that 3 and the x, whatever's on this side and this side, can just swap places. So 12 over 3 equals x, and therefore x equals 4. You can see that I've just put my x on the left-hand side of the equation. And that would, let's just say, well, 12 over x, we said x was equal 4 equals 3, so 12 over 4 equals 3. Yes, the left-hand side does equal the right-hand side. If we're doing the balance method, now we're just going to do it this way first of all. Okay, so another way to do this, I'll do this in a red pen. So I've got 12 over x equals, well, what we're going to do is just multiply both sides by x. So yes, this is the balance method. So 12 over x equals 12 equals 3x we're left with now. And then we can divide both sides by 3. and those two cancel each other out, and 4 equals x. And yes, we do know that left hand side equals the right hand side. Got a couple other problem solving sorts of questions here. Now here's one we've got. We've said that the length of a paddock is twice as long as it is wide. So if a farmer has like 1,200 metres of fencing, how long can he make the paddock? So just remember that the perimeter of a rectangle is 2 lengths and 2 widths. But we know that the perimeter is 1,200 metres. And we know that the 2 lengths here is the same as saying 2 widths. We said that the length of the paddock is twice as long as it is wide. So that's why I've substituted in L to say L is the same as saying 2 widths. So I've just rewritten this as an equation now. So I've just said 1,200 equals 2 times 2 widths plus another 2 widths. Well, that's going to say that 1,200 is the same as 6 widths. And then I can just say, well, 1,200 divided by 6 equals W. And then the 1 width equals 200 metres. So if I'm thinking about this, that's got to be 200 metres. And that's got to be 2 times 200 metres. That's got to be 400. That's 400. And that's 200. Now, does all of that add up to 1,200? Well, look, 6. That's 6 there. And that's 6 there and there. Yeah, so that's got to be all right. So we're happy with that one. Okay, I'd like you just to work on the mastery exercises and do your O-book assess before you move on, please. Year 9.